everyone, and then thank you very much to all of you for attending today. My name is Dr. Michele Vincenti, and I am the chair for the Leadership and People Management Department at University Canada West, and I will be co-presenting with Dr. Eric Korolenko today. First of all, we want to acknowledge that UCW is on the territory, and it's that the territories on which UCW and its campus are situated are the traditional and ancestral and unceded territories of the Musqueam, Squamish, and the Twistle Walnut. I'm not very good in those pronunciation. I hope your friends from First Nations will understand my challenges. So the topic we select, and this is a work in progress, is again a flipped learning models in the online courses. The purpose of this working in progress is that, of course, the university, we've been really forced, because, of course, of the COVID-19, to reinvent our delivery models, and we had to move into an online environment. And so our question for our research was, can flipped learning improve the delivery of the online process? And what we did, of course, we looked at secondary research, and we are counting on you for comment and more suggestions on how the researchers has to move forward. The overall I'm moving the screen, a presentation plan. Again, I'm going to show you the review of examples. So we gather information about 4 major examples regarding our topic. We look again at the divergence that we found. We will look at the positive interventions. Dr. Korolenko then will take over talking about the forgetting formula developed quite some time ago by Ebbina Gauss, also there, not sure if the last name is correct. And we will talk about the neural network in terms of long and short-term memory. And then we go to our conclusions, of course. So let's start the first of the 4 studies we have reviewed were conducted back in 2006 when basically the flipped method really started. This was done by Jonathan Bergman and Aaron Sams. So this is seminal work done in 2006. And the outcome of all of this was through basically to switch, because the students were advised not to take notes and go and look at the video. Just a reminder what the flipped means. There are sometimes a little bit of different terms that they are used, such as hybrids or others, but the whole idea is to share the delivery model between in-class and online. Which again, lots of educational institutions have moved because of forced by COVID recently. So what they found at that time was that again in 2007, everything basically was switched into a self-paced mastery model. They applied for grant, and they converted basically all the classes using the flipped learning. Now, Dr. Korolenko and I, of course, have reviewed in depth this article, and we found some challenges. No? So one is, of course, that changing the intervention method after only 1 year made it quite impossible understanding if there was any repeating effect of noise that is in terms of disturbance was too short as a time to make that statement. The fact that they applied for grant, again, that can definitely be biased, maybe even involuntarily, try to support the fact that the flipping was the only way. And then, of course, because they converted all the classes, there was basically no other way to measure if the other side, if they continue in the traditional way, they had any benefit. So from the research point of view, that first example as some challenges for us to accept the validity. Another big one was done again by the Roosevelt High School in North Dakota by Kay Ash in 2012. That's when she published actually the work. In this case, the result, we are giving to you the result of this big study. Some students excelled and some struggled. Some students did not progress in the study at all. Also, the other side to consider was the faculty, the teachers in this case. Definitely the flipped method didn't change magically the effectiveness of the faculty delivering the programs. Students were not completely happy about the model. They had the difficulty in engaging. And so at the end, the result about our analysis, as you can read yourself, converting all the classes to flipped, basically the control model was missing, and the research cannot really be compared because they switched all the classes and nothing could have been measured. So another bias there. The last two models, again, one is 2014. As you can see, we get much more closer to today's time. And also here, mixed things. One was, of course, the students favored the flipped classroom and over the traditional classroom approach. But from the other side, the traditional classroom, when I say lecturing, outperformed the flipped in terms of results. And this is with the non-parametric test, which is the Wilcox test to compare. The closest one study we reviewed was the 2019 aviation students. So as you can see, chemistry, high school, veterinary medicine, we tried to look at different academic dimensions there. Also here, the result was students in the lecture group had a significant high overall course satisfaction actually compared to the flipped learning. And the student in the flipped classroom did not perform better in the lecture classroom. Again, we were not really imparting for any model. Okay, so what we are reporting here is those kind of studies. So in the end, the divergence here is quite evident, and I think it's exactly as other two colleagues of us presented just a few minutes ago. At the end, they said that they found themselves at the crossroad. There are some pro, there are some cons. Also for us, we found very much the same thing. Student satisfaction with the flipped, it is no consistent pattern because of the biases I just mentioned to you before. The flipped learning combined with the self-paced leads to an overall decrease actually of performance. Another point that we looked at once again is that the flipped learning is not the panacea, but rather it's just a delivery method. And I think this one is also very true when we talk about research methodology, right? Some people think that just applying one research methodology is the solution versus, of course, it's just the method in which we apply our research. The flipped model does not work. And of course, the letter V and K stand for Vincenti Korolenko. It's our finding here as a working in progress. The flipped model does not work. It is better to change it to a model that works in terms of lectures, seminars, labs, and guided learning. And of course, the results also will vary depending by the group dynamic now, because also my PhD is in leadership. I always remind the students there is no best leadership style because, of course, it depends always by the leader, the situation, and and followers. So definitely we have a confirmation once again that there is no magic bullet, but we have always to consider the students, their situation, the faculty, of course, and they're in this. Another one which we looked at, this is my last slide before I move to Dr. Korolenko, is another big study done 2015. Again, this was really ambitious, actually done by Jay Hattie, and he reviewed 1,200 meta-analysis on the effect of different interventions. So we are not talking about only about the flipped model. Once again, what we had is that some positive in terms of almost everything, any intervention showed some achievement in terms of gaining. So definitely it's very encouraging that we have to continue moving forward with some sort of intervention. The other side, again, because 1,200 meta-analysis and comparing them using a different methodology, different things at the end, I'm sure, you know, with our audience of all PhDs, we understand that we have the risk to compare apple with oranges at the end. And so another one, a big one, was done with 887 studied here of Tomcho and Foyle in 2008. Intervention positive. So once again, we are on the right track in experimenting and trying to do things. The other side showed the negative effect. Of course, there is always something there. And endemically positive, definitely the result. So at this point, I will pass. And by the way, this is a little bit in Latin. I studied Latin for 8 years as an Italian. Finally, I have used it today after a long time. Dr. Korolenko, your time, please.
Thank you very much, Dr. Vincenti. We have now just finished with the first part of the talk, and the second part of the talk is how did this all ideas about forgetting and learning have come to be? And so this, of course, is not a very new subject, because learning has been a topic of interest for, I guess, millennia, if not more. But in more contemporary times, although far remote from today, we had the work of Hermann Ebbinghaus, who published in 1885 a contribution to experimental psychology. Now, he did publish it in English, he published it in German, but it was important enough that it got translated into English. Next slide, please. So the contribution of Ebbinghaus was to invent a formula that describes the results, the outcomes of a particular experiment. And from his original work translated here, the amount which is remembered from the first learning depends on the time elapsed since the learning has been completed. And then there are two parameters, which are C and K, which can be adjusted in order to fit this time dependence to the actual data. And so the general result was that as we have time passing, the more and more of what we have learned has been forgotten, which is, we can note, not a very surprising observation. By the way, if you want to find the works of Ebbinghaus, you have to go to archive.org, which saves them there for you for free. Now, the interesting part, though, is that the benefit of studying the primary source is to find out what kind of results did Ebbinghaus consider when he was developing his formula. So what he did is he created essentially a sequence of meaningless syllables. And he tried the best that he could memorize those, and then he would note as the time would pass how much of these syllables he remembered and how much did he forget. So This is, of course, an exceptional case because he, being the researcher, he would be most motivated to try to remember the best. He was also the one who designed the experiment, and most likely he might have been also the one who wrote the syllables in the first place. In absence of motivation, of course, the results could be quite different. And they could be quite different also because if your original memorization can at all be compared with what was the original, what you read. So what you read and what you memorized could be not the same. Well, for Ebbinghaus, it was easy to compare because he had a sequence of syllables, which could be compared with the other sequence of syllables that he would write down. That is, of course, not the same as understanding of what you have learned. You know, if you go back to Bloom.
15-minute mark.
Thank you. And also the understanding doesn't equal the ability to use, as we all know, and Bloom, of course, also mentions that, but it's been known as many things way before Bloom. The learning that Ebbinghaus started, it was not anything but just rote memorization. It was not associative, it was not synthetic. The conclusions, therefore, would be similar to what you get in rote memorization. And an example that comes to mind, of course, is memorizing numbers from the phone book, and very little else, because much of what we learn is not learning meaningless things. The things have meaning, they have the meaning, and the meaning is enhanced by connecting them to other things. And so in a classroom, these results may apply very differently. However, this seminal work, even today, is referred as a foundation of the memorizing and forgetting, even though by its essence, it's not exactly how the learning of material in classroom is in fact proceeding. Next slide, please. So now we want to bring some information here, which is related to a very contemporary topic of machine learning. Now, usually machine learning is an attempt to recreate what is happening in our brain by an abstraction, programming abstraction, and make it happen in hardware, such as computer hardware. This we would like to reverse a little bit and to try to see how do the results from what we learn from observing the performance of neural networks, how they could be applied to learning in the brain. Classically, the neural networks can only do extremely simple problems. The usual classical neural network, which was a perceptron, could not do even some simplest logical problems. Addition of nonlinearity allowed to solve arbitrarily complex problems, and layering, multiple layers of nonlinear processing allowed to essentially recreate any function desired if you had a neural network. That said, these methods had issues, and the biggest issue was that the more complex the network would become, and the more layers it would have, the slower it would learn. So either it would learn slowly or it would become unstable. A solution was found in 1990s by Hochreiter and Schmidt-Huber, and the solution was to introduce something which was called a memory carousel, or constant error carousel, which made each layer or each cell remember its own error regardless of how the learning elsewhere was happening. And this allowed to speed up immensely the learning process, but it was not the only contribution. The second contribution was that the cells in those long short-term memory networks were allowed now to forget. And so they would learn information, but if the information was not sustained, it would start to fade out. And that was why the forgetting part was one of the reasons why those networks became so fantastically effective. So if you see your handwriting recognized, if you see your postal code automatically recognized, if you see a nameplate on your car recognized by police and so on, this is because systems similar to LSTM, GRU, or whatever other more variations on the same topic have been employed.
19th minute mark.
Yes, and
maybe you can do
maybe
the
we skip
conclusion.
one slide.
We can go to conclusion. Yes, please.
Yeah. So the point of this is we need to allow enough relaxation for students to forget. You know, similarly to neural networks, the students are not able to hold all information in their mind. Forgetting and relearning is not a bad thing. The forgetting of something is not the point. The point is able to synthesize and apply information in new situations. So let's go to the conclusion slide. And so as we said, we have found out that flipping is not a panacea. It's not a correct focus even. It's just a method of delivery, and it's not much different from asking to read ahead. Satisfaction of students is inconsistent, depends. Sometimes they are less satisfied, sometimes more. Results are also not consistent, and overall they are even less successful than traditional learning. The focus that we should have is on generalizing and applying information in new situations. And so to forget is not bad. Forget and relearn is in fact wonderful. Thank you.
Thank you very much.